Hello everyone, good evening. We were solving the sample questions from the paper for BSDS 2024 and now we're at question 29. So question 29 is based on matrices and upper bounds. So you might think that's a weird combination, but what can we do? We have to solve this one. So how would you go about it? So first let us understand the question. The question says A is a 2 by 2 matrix with positive entries bounded above by a constant. Alright, so let us assume any matrix, right? So let us take A, sorry, A equal to something like A, B, C, D. Now each of these elements, right? So all A, I, J is less than A, alright, bounded above, and this constant is positive. Okay, now let us see what happens at A square. So A square will be A, B, C, D into A, B, C, D. Now do this matrix multiplication and you will end up at A square plus BC, right? A square plus BC, then we have AB plus BD, then we have AC plus DC, BC plus D square. Now each one of these elements, A was bounded by small a here. Each one of these elements were less than A. So I can say that this is less than A square plus A square, A square plus A square, A square plus A square, and A square plus A square, which is equal to twice, right? So elements of A square are bounded by 2A square. Do you all agree to this? We did not do anything fancy, we just multiplied the stuff and we checked that since each of these values are less than A, when we are multiplying we are including two copies of them, right? Whether they are the same copy or the different copy doesn't matter. The maximum of each of them is 1, is A, right? So whether it's AC or BC or DC or A square doesn't matter. A is less than, capital A is less than small a, C is less than small a. So the product of A and C would be less than the product of small a into small a, which is A square. Alright, so AC, DC, BC, whatever terms you take, two terms together will be less than A square. Now we have established this. So just raise everything to the power 5 and you should get your solution. So A square to the power 5 should be less than 2A square to the power 5, which implies A to the power 10 should be less than or equal to 2 to the power 5 A to the power 10. Okay, option B. I hope you could understand this. You just had to do one matrix multiplication and then continue it. Alright, this sum was a bit weird if you have started multiplying the entire thing, and it would be a bit difficult if you assumed a matrix, right? You can assume a matrix. You can take A to be the identity matrix. If you take A to be the identity matrix, then each one of these will be the solution, right? Because it's 1 0 1 0. Right? Similarly, you can take a matrix and check which of the values will follow, but then you have to also select a certain upper bound, right? And the upper bound could be anything. So let's say my matrix is 4 ones, right? A equal to 1 1 1 1. Now 2 could be the upper bound here, right? I can also put 10 as the upper bound. So all of your calculations will become quite, you know, unspecific, because first of all the four elements of the matrix are unknown and the upper bound is also unknown. Because it's a positive constant, I can take it to be anything, right? So I hope you could follow my logic. I have just calculated the value of A square, taken it to be less than the value of small a, and then multiplied by and then taken power 5 left hand side and right hand side, so I got option B. Okay, if you have any questions or comments regarding this video, do post it to the numbers that is given in the comment section, and I'll see you all in the next video for question 30.